There are two isotopes of copper. Copper-63 is 69.17% abundant, and it has a mass of 62.9296 AMU. Copper-65 is 30.83% abundant, and it has a mass of 64.9278 AMU. Calculate the relative atomic mass of copper. So the equation to calculate relative atomic mass, so relative atomic mass, which is RAM, abbreviated to RAM, is equal to the atomic mass of isotope 1 multiplied by the percentage abundance plus the atomic mass of isotope number 2 multiplied by the percentage abundance. All of this then gets divided by 100. So let's now go to our question and say, hey, where's all that information? Alright, so for starters, isotope number 1, if we call it copper-63, there's its percentage abundance, and there's its mass in AMU, so that's its atomic mass. There's copper-65, here's its percentage abundance, and here's its mass in AMU. Alright, so we've got all the information we need to solve for this unknown. Let's go and do that. So the atomic mass of isotope number 1 is 62.9296 AMU, and that needs to be multiplied by its percentage abundance. Now it's really important when you enter in the percentage abundance that we don't put in the percent sign. And the reason why we don't put in the percent sign is because if I wrote in 69.17%, there's a tendency for me then to write into my punch into my calculator 62.9296 times 69.17%. And if I do that, it'll give me what and if I do that, the calculator is going to tell me what 69.17% of this number is, but really I'm not after that. I just want this here as my abundance of this isotope in reality. So what I'm going to do, I'm going to leave this as 69.17 without the percent sign. And then I'm going to close my brackets, and then I'm going to add to this the atomic mass of my second isotope, which we're going to call our second isotope copper-65. And here's its mass, so 64.9278 AMU, multiplied by, again, its percentage abundance, just as a normal number, 30.83. And then I'm going to divide that whole top line by 100%. So now let's go to our calculator and put all this information in and solve for our unknown. So open brackets, so 62.9296 multiplied by 69.17 plus 64.9278 times 30.83, close brackets. I'm going to solve for the numerator first, and I'm going to divide that whole answer by 100. And so the relative atomic mass of copper is equal to 63.55. So relative atomic mass is equal to 63.55. And the units for relative atomic mass, well, there isn't any because it's an average, so we don't have to put anything afterwards. So let's have a look. We've got all our equal signs lined up. We've got our equation, our full working, our answers underlined, and there we go, all done.